Hello, good afternoon, ladies and gentlemen. My name is Lee Hyun-ho, professor at Dankook University, serving as vice chairman of the 5G Forum. My main responsibility is international collaborations. So I'm happy to moderate this session 2, Industrial 6G Strategy and Prospect. So at this session, we invited leaders from global industries, 3 from global company and 2 from Korean leaders. So first, I will introduce Mr. Peter Better of Nokia North America, serving as CTO. So he will give a 6G generational shift to augment human existence. So let's welcome him.
Thank you for inviting me. I'd like to talk to you about 6G and how that will augment our human productivity. But before talking about the next generation, I'd like to take a historical perspective. Our industry has been very good at turning out a new generation of mobile networks every decade. And in every decade, we saw new radio technologies aiming at higher and higher frequency ranges and aiming at new applications, from voice to texting to internet to video. And with 5G, for the first time, we're not only connecting humans, but also machines. Every generation also saw new compute platforms. In the 80s, I did my PhD on a VAX mainframe computer. There were also IBM mainframe computers. But then in 2G, that shifted to PCs. These PCs became mobile with the laptops in 3G, and the handsets in 3G became compute platforms. An important paradigm shift happened in 4G with the cloud and applications running from the cloud. But now that we are in the 5G era and are connecting also machines, latency is very important, and we'll see the distribution of clouds to the edge to really guarantee millisecond latency for the control of these machines. In every generation, also the value has shifted from the network to devices, between hardware and software, and back and forth. You see that here highlighted in light blue. So in 1G, the value was really in the hardware. Such an analog handset that was very expensive. It was a status symbol. And also these compute platforms, they were very expensive. The human-machine interface was not friendly at all. I mean, I started with punch cards, and then you had these monochrome alphanumeric displays. All that changed for the PC in the second generation. It was a very well-designed operating system and a Windows-based human-machine interface that enabled new applications. The network matured from ARPANET to the World Wide Web. It was also the emergence of the digital mobile telephones that valued the network. The human-machine interface on the handsets was not very good. It was just a numeric interface. That changed in 3G with these devices. A well-designed touchscreen, a well-designed operating system that allowed for a plethora of new applications. And the network continued to be very valuable. So the hardware was very valuable. That continues also in the 4G era, but with the deployment of applications from the cloud, things were more delivered, services were more delivered over the top, and the network devaluated. But we're also saying that it's going to be the end of these type of devices. In the 5G era, we'll see a plethora of new devices and sensors. So unlike this device where all functions are on one handset with the camera, the microphone, the touch screen, the display, now the interaction, the human-machine interface will change with voice recognition, gesture recognition, goggles, so complete disaggregation. Also, rather than having multiple applications on a single device, we'll see multiple devices aggregated into a single application. Some of these devices won't even have enough compute power for a decent operating system and software. So the applications will run in the edge cloud. And to connect all this, the network will become very valuable. So where do we go from here to 6G? And 6G is still a decade out. There's a lot of innovation still in 5G with new releases of the standards. But in research, we need to start thinking about the 6G era, which is in about a decade in 2030. And what we will see is, new radio technologies aiming at even higher frequency ranges, terahertz. There's already research ongoing on that. In addition to new applications that connect humans with machines, we will also connect humans with the digital world. And I'll elaborate a little bit more on that. And the compute platforms will use massive scale artificial intelligence. The value will be in the data, in the information, in the intelligence, and in the network that connect all these intelligence platforms with the devices and the sensors. The human-machine interface continues to be important and will evolve further. We will create a network with what we call a sixth sense that intuitively understands our intentions, and in this way makes our interaction with the physical world more effective, anticipating our needs and improving our productivity. So here we see a simple representation what 5G has done. It has connected humans with machines. What 6G will do is we will see a much richer connectivity of the physical world, a much richer connectivity of our own biological world, and massive scale deployment of sensors will allow us to synchronously update digital models of those physical and biological worlds in the digital world. Now, why is that so important? Well, then you have these digital models that you can use to transport them, make modifications, and print them as a new product in the physical world. You can transport a model of yourself. I can then be recreated in a holographic representation, for instance, and I can be there with you as if I were there. These digital models also allow to make predictions, simulate possible outcomes, and make effective actions back into the physical world. The digital models of ourselves, of the biological world, will enable new healthcare and also help us to understand emotional state. And that emotional state will help to understand our intentions, understand our needs, and more effectively help with the interaction with the physical world. All that is to augment our human productivity. So let's have a look at that. So here is some data of a book of Robert Gordon of the productivity growth in the past century. And what we see in the first half, that the productivity growth increased year over year until the middle of the century. And that is thanks to inventions in the second industrial revolutions like steel, transportation, petrochemistry. Now that productivity growth goes back to zero, which means going back to stagnation, despite the fact that we invented such things as the internet and mobile networks. Now, why is that? Well, the internet and the mobile network has been designed for consumers. It's been used for consuming video clips, for shopping, so it's not very productive. Now, all that should change with 5G. It helps to look at our industry, and you can divide the industry in two types. There are the digital industries, like e-commerce and finance, that embrace the digital technologies. And though they're only 30% of our economy, they invest 70% of the total ICT spend. And they are at that almost 3% productivity growth year over year. Now, the physical industries, think retail, transportation, mining, they are the largest part of our economy, 70%. But they spend only 30% of the ICT. And they are at that sub 1% productivity growth. And the whole idea of 5G and industrial automation is to bring these ICT technologies to these physical industries to enhance their productivity. And there's an example like Alibaba or Amazon that have done that very well for the retail industry. Now, in order to enhance human productivity, there's a big problem coming ahead. The amount of knowledge and information is increasing more than exponentially. And I'm not talking data, I'm talking really about learned information. It's been doubling every year. And the prediction is going to double every day. And there's bad news. We humans are not good at handling knowledge. What this graph shows here is that you will have forgotten most of what I said in 1 month from now. So we need help. And the digital of managing all the information in our physical and digital and biological worlds. There's already digital twin models for enterprises, for smart cities, and we'll see more and more also digital twins of humans. And that will have an enormous impact on the way we deploy our network. You see here the network architecture with the access network, the anyhall, the distributed edge cloud, an IP transport network, and connecting all that with the central cloud. And now going forward in 6G, there will be massive deployment of sensors that continuously send upstream data in a very greedy way to intelligence platforms. And in these intelligent platforms that are distributed across the network, they will also synchronize each other and update the digital twin models. So that will require enormous capacity and highly extreme synchronicity. To make that happen, there's a number of key research areas that we need to address in 6G. And guess what? There's 6 of them. First of all, we will see use of AI ML for new radio interfaces, very different from the way we do it today. Clean slate designs. We will see new spectrum technologies in the existing bands as well as in the new terahertz ranges. And it's not only about communication, it's also about enabling sensing, using that ubiquitous radio infrastructure to understand the physical world. We will see new architectures already now with virtual RAN and cloud native design principles and new processing capabilities. This is a moment to have a fresh look on how we deploy radio access networks and core networks and enable new deployment models as a service. We'll also see extreme connectivity requirements, networks of networks, where at the endpoints of the networks, we will have again a network, a body area network, a machine area network, with very specific specialized requirements in latency. And all this needs to be designed with the highest security and trust. I don't want my digital twin to be hampered with. So security cannot be an afterthought. It needs to be designed in from the ground up. So let me elaborate on a few examples. Here, using AI ML for communication across a channel from A to B. And across decades of engineering, we came up with well-known models of transmitters and receivers with their respective functional blocks. And increasingly, today we start using AI ML to optimize the performance of individual blocks. AI ML for MAC scheduling, AI/ML for digital pre-distortion as a few examples. But now imagine that we take a clean slate approach, that we do away with the complexity of all these digital signal processing layers, and that we just let an AI/ML engine figure out how to best communicate between A and B in real time. I have done first experiments already doing exactly that on a radio channel with varying radio conditions. And the system figured out itself what the best constellation is. The radio technology will also change. We will see new technologies in the existing mid-band frequencies that allow for lower power consumption, lower cost, and easy to use form factors. You, for instance, can have these thin flex foils behind picture frames, behind billboards, and allow for low-cost deployment of ubiquitous radio around us. In millimeter wave, we are already researching low-cost 90 gigahertz millimeter wave, so the higher bands of millimeter wave. You see here a transceiver silicon circuit for millimeter wave with 16 transceivers and a low-cost antenna array with tiles of these transceiver circuits achieving up to 400 antenna elements. And going to terahertz, we have research going on radio and glass, because glass is a good material for terahertz frequencies and achieve systems at a low cost. And it's not only about connectivity, it's also about sensing. And we are already using radio for localization. Here in this example, you see a layout of a home, and the red dots are Wi-Fi access points. And you see the blue dots appearing, they are tracking this person walking through the residential setting. Now going forward to 6G, where we will use millimeter wave and terahertz, it's not only using them as a radar for localization, there's also material-specific back reflections that allow us to get a much richer content of information. Now combine that with AI/ML, and you get a much richer understanding of the physical world, ability to predict what's going on in the physical world. We call that a network with a sixth sense. So in summary, we'll see a generational shift in 6G that will allow us to augment our human performance. And I've explained how we will be connecting physical and biological worlds with the digital worlds through the massive scale deployment of sensors and intelligence. And that will require extreme capacity and high synchronicity of that 6G network. And in this way, we will create a platform with a sixth sense that augments our human existence. Thank you.
Thank you, Peter Better, for your nice presentation. So he characterized the 6G as a combination of physical world, digital world, together with the biological world. I think the combination of biological world will give us good sign, because currently many of us are suffering from COVID-19 pandemic. But if we provide some solutions with digital technology in 6G to solve the problem, that will give us good sign for all human beings. Okay, thank you.